Hey everyone, welcome back to the channel. Today we're diving into phasereditor v4 to create something really exciting, a retro-inspired infinite jumper game. Think of the classic pixel art vibes of games like Metroid and Super Metroid, but now you're building it yourself. This is what we'll be creating by the end of this video. A fully playable infinite jumper with smooth parallax background, custom fonts, and dynamic gameplay. phasereditor v4 makes building HTML5 games faster and more accessible than ever. With its visual tools and just a little coding, you'll be amazed at what you can create. In this tutorial, we'll cover how to create reusable game objects using prefabs, building beautiful parallax backgrounds with TileSprites, handling player input for smooth and responsive controls, connecting multiple scenes to create seamless gameplay, adding personality with custom fonts, and much more. Before we get started, a quick heads up. To follow along, you'll need phasereditor v4. I won't be covering installation in this video, but I've included a link to the official documentation in the description below. So whether you're a seasoned developer or just starting out, this tutorial will guide you step by step to create an awesome game. Ready? Open up phasereditor and let's jump into it. So before we dive into our project, I just want to give a big shout out to Ansimus. So all of the assets that we use in our project today were currently created by him. They're available as part of the Legacy collection over on itch.io, and there's going to be a link down in the description below to this asset pack. And so this asset pack has a variety of assets that you can use for your game. There's characters, backgrounds, and they're all for a variety of different themes, so I definitely recommend that you check it out. To start building our game, we need to make a new project in phasereditor. Let's go to New Project. Let's use the basic JavaScript built-in template. For this, now let's make a new folder for our project, and I'm just going to call this Infinite Jumper. Let's open up that folder, and now phasereditor will go ahead and clone our starting project template files into our local project. Alright, so once our project is ready, we can choose Open a Scene, and now we can choose our level scene from our starting project, and we should see this dinosaur with our starting text. Alright, to make sure everything's working properly, let's go ahead and click on the play button up here. This is going to start the local dev server and open up our project in our browser. If you navigate over to your browser, we should see our dinosaur with our text, and if we click on the dinosaur, we should see our text gets updated. Finally, if we just go into our developer console, we should see our Phaser banner with the version of Phaser that we're currently running. Alright, so for our project, the first thing we'll do is let's update our Phaser version. If we open up our index.html, we're currently pulling the Phaser framework from the CDN. For this project, we're going to be using Phaser 3.87. Newer versions of Phaser should work, but you'll need to be on at least this version to follow along, since we're using custom fonts. Alright, so after this change, if we go back to our browser, if we refresh, we should see our banner's been updated to use 3.87. So now we verified our project's working properly, we're going to go ahead and clean up some of the assets from our starting project template. Let's remove our dinosaur and our text from our level scene. Let's open up our level.js file, and inside here, we'll also want to remove where we have this.dino, where we listen for a pointer down event. Let's remove that logic since we removed our image. Alright, besides our level scene, let's go ahead and clean up our preload scene. Let's open up our preload.scene file. Inside here, we're going to have this image, so let's remove this fruit, and then we'll keep our text for our preloader. Alright, next, let's go ahead and clean up our assets for our games. We're going to our assets folder. Let's remove our dino and our fruit. So we'll go ahead and delete those files. Since we deleted them, we need to update our asset pack. So if we go into our preload asset pack, let's get rid of our image here. We'll save. If we go into our asset pack JSON file, let's get rid of our dino and let's save. Alright, so come back to our browser, we should be able to test. Let's refresh our game. We'll see now that there's nothing in our scene, but our game is still working since we can see our background color for our scene. Alright, so for our starting project, we're going to make one more change. Let's go into our main.js file. Currently, our Phaser game is set up to have 3 Phaser scenes. Our first scene is our boot scene, and this is responsible for loading in any assets that we'll need for our preload scene. And then we transition to our preload scene once those assets are loaded, and then that is responsible for loading the rest of our assets for our game. For our game, since we're no longer using any assets in our preload asset pack JSON, we're going to remove this scene here. So let's get rid of our boot scene. Alright, then in our code, where we add in our various scenes, we'll want to update our preload scene, and we're just going to change this to say true, so it starts our scene automatically, and we're going to move this line below our level scene. So let's go ahead and save our code. Let's come back up to our assets folder, and let's get rid of our preload assets pack JSON file. Now if we delete this, and we save, alright, so if we come back to our browser, we should be able to test our changes, we should see our game still loads, and we still see our background color for our main scene. Now we've updated our starting project template, we now need to load in the assets we'll be using for our game. So in the description of this video, there will be a link to this page here, as well as the direct download for this asset zip folder here. That zip folder is going to have all of the files we'll need for our game, so this will be our sprite sheets, our images, and our custom font files that we need. If you can go ahead and download that zip folder now and extract the contents, you should see the following files. Alright, so inside that assets folder, there'll be three main folders: tiled project, script notes, and assets. For this video, we can ignore the tiled project. This just has some of the tiled files that were used to create some of the game assets. Script nodes, this will have a variety of useful script nodes we'll be using for our game. Then finally, assets has all of the images, our custom fonts, and our sprite sheets that we'll be using to make up our game. So let's jump back over to the phaser editor, and now we need to load in the assets for our game. To do this, we want to click on our assets folder, and now in our inspector, we can either drag and drop our folders or do browse files to add in our files. So to load in our assets, I'm going to drag and drop our 4 folders over to our assets folder. So now what that'll do is that's going to copy our assets over to our project folder. So we'll see we have background, font, other, and then player. Now that we have our assets, we now need to add them to our asset pack file. So let's go into our background folder and choose our 2 background images. We're going to do import as image, and we'll add that to our asset pack JSON file. For our font, we'll click on our font, we'll do import as font, and we'll add that to the asset pack JSON file. Now let's do the same thing for our other folder. So we can just load in these 3 as images. Then finally for player, we'll choose both of our assets, and we want to do import as atlas. And we'll add that to our asset pack JSON file. And now if we open up our asset pack JSON file, we should see our various file types with our files. So we have our 5 images, our 1 player atlas, and then our custom font. Now that we loaded in the assets for our game, we can start creating our various game objects. For our first game object, we're going to focus on our platform. And for our platforms, we'll be creating multiple instances of this game object. We'll go ahead and start off by creating a prefab that's going to represent our platform. To do this, let's jump over to our level scene. Under our source folder, let's make a new folder for our prefabs. So we'll do new, we'll do folder, let's do prefabs. Create a prefab. If we go to our prefabs folder, we'll do right click, we'll do new, let's do new prefab file. And I'm going to call this platform prefab. Alright, so now we need to choose our basic game object that our prefab instance will extend. For our platforms, these are going to be an image that have a physics body that our player will be able to interact with. So for our built-in types, let's go to arcade, and we're going to do arcade image, and let's drag that into our scene. Now we'll be able to choose the texture that we want for our prefab instance, and let's choose our platform. Now it's going to create our new image game object, our arcade physics image game object in our scene. So let's update our position. So for our transform, let's do 0, 0, so it's in the top left-hand corner. Alright, so now for our prefab instance, we're going to modify our scale property. So we want our game object to be a little bit smaller. So for this, let's do 0.75 for our X value, and let's do 0.5 for our Y value. Alright, so if we come back to our level scene, we should now be able to create an instance of our platform prefab. So from our built-in blocks, we should see under prefabs, we should see our platform. If we drag it into our scene, alright, so we'll see our game object appears, but it's very small when we compare it to the border of our level. So for our game, we need to update our settings. So let's go into our main.js file. Currently, our game size settings are as 1280 by 720. But for our game, we'll be targeting a much smaller dimension size, and then we'll let our game automatically scale up to fill up our browser window. So for the size we're going to target, it's going to be 240 by 176. And so while we're in here, since we'll be using pixel art for our game, let's add in that property. So we're going to do pixel art, and we're going to go ahead and set this to be true. So now back in our level scene, let's update our border for our level. So this will match our game settings. We'll do 240, and let's do 176. All right, so now if we take our game object, let's position it at 0, 0. And now if we zoom in, we can see our game object. And let's drag that into the center of our screen. So we'll take our translate tool, and let's go ahead and move it around here. Let's go ahead and save. Come back to our browser. Let's test our changes. Oh, we'll see we have an issue with our platform prefab. Yes. Since we extended an arcade physics game object, we actually need to add arcade physics to our game configuration. So our main.js file. All right, so now what we need to do in our game configuration, we'll add in our physics property. For this, we'll add in the object. And first, we'll do our default property. So this is our default physics type, and we're going to do arcade. Now let's add in our arcade property. Let's do gravity. This will be an object. For X, we'll do 0. For Y, we'll also do 0 for the time being. And let's add in debug, and we're going to set that to be true. And that's just going to allow us to see our physics bodies in our game while we're testing. When you're ready to release your game, we just want to make sure we set that to false so they're no longer visible. All right, come back to our browser and refresh. We should now see our platform, and we shouldn't see any errors in our console. And so this purple bounding box, this is our arcade physics body when our debug is set to true. To see an example, if we just set this back to false and we come back to our browser, we'll see that purple border now goes away. Now that we have our platform game object, we need to work on spawning multiple instances of our prefab into our game. So when a player lands on our platforms, they're automatically going to jump up to higher in our level, and we need to have a platform available for that player to land on. And so what our level is going to end up looking like is we're going to spawn different prefab instances at various X and Y values throughout our level, and as the player jumps up, they're going to be able to land on these different platforms. Now we want these to be dynamic, and we'll also want to control the number of platforms that are actually spawning in our game. And so we could take the path of just continually spawning new platforms as our player progresses higher and higher up in our level, but eventually we're going to have all these additional platforms down here that are no longer being used, and they're just wasting resources in our game. To control this, we'll want to clean up these platforms when our player moves above them, and then our game will end when the player drops below the lowest platform that's currently available. And so to do this, typically you'd want to use what is called an object pool. Our object pool allows us to create a set number of game objects, and we can control the max number of game objects that are available to us from that object pool. We can then use that pool to find objects that are no longer active and then reuse those game objects so we can then spawn them in a new location. And so what this would look like is, instead of having all these game objects, let's just remove these ones up here. Let's say our player's on this platform right here, right now, and they're jumping up. What we can then do with our object pool is we can grab this game object down here that's no longer in use, and we can now respawn it up here. And as our player moves up, we're going to keep doing this pattern where we're grabbing these objects that are no longer being used, and we can just keep updating their positions. And by doing this, it allows us to reuse these same game objects throughout our level without having to spawn an infinite number of these game objects. And this is the approach we'll be taking for building our platforms. Now to do this, we're going to use a native game object to phaser that's called a group. And our group has a bunch of built-in properties for allowing us to manage the pool of objects that are in that group. And so real quick, I'm just going to clean up our platform prefabs from our level, and let's go ahead and create our new group. To do this, we'll make a new prefab instance to manage our group. So under our prefabs, let's do new. Let's do a new prefab file. I'm going to call this platform group prefab. So for our base game object, let's go into group, and let's drag in an instance of our layer block. We'll save. Now when our platform group prefab.js file is created, let's open that up. And now we'll want to create our phaser group. So in our constructor, we can add in our custom code. Let's do this. We'll do group. We're going to set it equal to scene.add.group. And now for our group configuration, let's pass in class type. So now for our class type, we want to do our platform prefab. So we're going to do platform prefab. So now we need to add this as an import into our class. So at the top of our file under start user imports, let's do import our platform prefab from, do // our platform prefab.js file. So what this configuration will do is, from our group, anytime we create a new game object instance from our group, it's going to use this class type as our object that gets created. And so this is how we'll control our game object that's created will be an instance of our platform prefab. So now we created our group. Now we can create instances of our platform prefab. To do that, we can do this. We'll do our group. Now let's do get. And now we can provide the position of where like our game object to be positioned. So let's do 90 and we'll do 0 for our position. All right, so what this group.get does is when we have a phaser group, when we call the get method, phaser is going to return the first eligible game object to us. And if one's not available, it'll create a new game object instance for us and add it to that group. And so what phaser does internally is if our game object is not visible and not active, it'll be considered dead, and we'll be able to reuse that game object when we call our get method here. If we don't have any objects in our group, or if all of them are considered alive, then phaser will create a brand new instance of whatever class we provide here. And so this is how we'll be able to reuse our objects for our object pool. And so to limit the number of game objects our group or our object pool will be able to actually create, we would want to specify our max size here with some number. For the time being, we won't be setting this, but that's how we could control our object pool. So one other thing we're going to do is if we want to have our IntelliSense show us what's available on this group, we need to add that to our code as a type. So we'll come down below our constructor, and so we can do our start user code here. Let's add in group as a property on our class. And so now we'll just add in the JS type for this. So we'll have our IntelliSense, we'll do at type, let's do phaser, we'll do game objects, and now this will be a group. So now when we hover over get, we'll actually get the IntelliSense and the documentation for our methods. So now if we save, let's come back to our level scene, and let's drag in an instance of our platform prefab group. All right, so now if we save, let's jump over to our browser, and what we should see now is when we refresh our game, we should see our platform being created at the position that we specified. Since we set 0 for our Y value, our game object's up at the top, so let's come back to our code. Let's update our prefab. So let's do 150 for our Y value. Now if we save and we refresh, we'll see now we can see our platform in our game. All right, so now we have our first platform in our game. Now we need to create multiple platforms that our player will be able to jump on. So back in our code, let's do a for loop. We'll do for. We're going to do let I equal 1. And if I is less than 5, we'll do I plus equals 1. And now we want to do the same thing. We're doing this group.get. And now we want to do a dynamic X and Y value. So for our X value, let's set it equal to phaser. We're going to do math. Let's do between. And we're going to do 10 and 200. What this utility method does, it allows us to generate a random number between two values that we provide. So by providing 10 and 200, Phaser is automatically going to choose a random number within this range, and both of these will be included. Now we want to do our Y value. All right, so for our Y value, we want this to be dynamic based on our I value. And for this, as we're adding in our platforms, we want them to be placed further up in our scene, which means there'll be a negative value. So for this, we'll do const y, and we're going to do minus, we'll say 20 for now, and we'll do times I. And now we want to start from our initial starting position, which is 150. So let's add that in. And now when we grab our game object from our group, we want to do X and Y. Now if we save, we come back to our browser, let's refresh. Oh, we have an issue. This should be phaser math.between, not phase. Much better. All right, so what our code's now doing is we have our starting platform, and then our for loop, we're creating 4 new platforms at random X values, and then we're slowly moving them up our scene. So let's bump up our gap. So let's just do 40 pixels for the time being. All right, so if we save and refresh, we'll see now our platforms are being generated, and now they're moving up in our level. And so if we refresh our scene, we'll see we'll have a bunch of different placements for our platforms. Now that we created our initial platforms for our game, we're going to pause working on our platforms and work on adding in our player. We'll add in our player game object so that way we can start testing our game as we're writing our code. So let's jump back over to our editor. Let's make a new prefab for our player. So under prefabs, we'll do new. Let's do a new prefab file, and we're going to call this player prefab. So for our base type, let's do arcade, and we're going to do an arcade sprite. So we're doing an arcade sprite because our player will be animated versus our platforms. We're just doing an image since we're not doing any animations. So now for our texture, let's choose our player idle animation 1. If we zoom in a little bit, we'll get our full name like this. I'm going to zoom back out a little bit. So we have our player idle 1. Let's select that texture. Let's update our position. So we'll go with 0, 0 to be in our top corner. All right, so for our player game object, we're going to see that our rectangle is quite large, and that's just because of the sprite that we imported. Due to this, our arcade physics body is going to be very large for our games. We're going to modify this for our player. So for our body, let's come down to our arcade physics body geometry. For our size, let's change our width to be 11 pixels, and we'll do 44 for our height. So now we'll see our body's much smaller, but now it's not centered over our player. To fix this, we need to update our offset. So for our offset, let's do 35 for our X. And now for our Y, we'll do 20. And now we'll see our arcade physics bodies over our player much better. We need to update our collision checks for our player. So for our player, we want to be able to collide when our player is touching down on a game object and when we're touching left or right. So like when we collide with the walls of our level. But we don't want to check for collisions for up. So then that way our player can move through our platforms. So let's deselect that. And now let's save. Now that we have our player prefab, let's jump back over to our level scene and let's drag in an instance of our player. So for our player, let's drag that into our scene. Let's save. Now if we come back to our browser, if we refresh, we'll see our player's game object has been added. And let's place our player over a little more to the side so it's over our platform. All right, so if we refresh, we'll see now in our scene, our player's over our platform. And we'll see that our platforms are very close together when we compare it to our player size. So let's jump back over to our platform group real quick, and we're going to update our positioning. So let's do minus 150 for our value. So if we save and refresh, we'll see our platform's now at the top of our scene, and our player's gonna have to jump to get to it. Much better. All right, so now we have our player game object. If we want to start testing our code, we actually need to update our gravity value, so then that way it can be applied to our player. So if we come back to our code, let's go into our main.js file. For our Y value for gravity, let's update this to be 300. If we save and come back to our browser, what we should see happen is now all of our game objects are added, but now that gravity is being applied, they're now all falling in our level. To fix this, we need to update our platform so then that way gravity is not being applied to them for our Y value. So if we jump back to our code, let's go into our platform prefab scene. Alright, so for our platforms, if we don't want gravity to affect our platform, under our arcade physics body movement, let's deselect our allow gravity checkbox. Let's save. If we come back to our browser, we'll see now our platform is in our stationary position, but our player now falls through our platform. Now what happens by default when we add in our physics, and we can see our physics bodies here, Phaser is not going to have any collisions between our game objects unless we tell it that we want them to collide. And to do this, we need to create what's called a collider. And so what the collider will do is going to allow us to just tell Phaser which game objects we want to check for collisions with. So this is going to allow us to check for collisions between our player game object and all of our platform game objects here. So back in our level scene, let's add in our collider. And so to do this, we'll go under our built-in blocks. Under arcade, let's add in a collider to our scene. So now we'll have this new collider. Let's update our name, and we're going to call this player with platforms collider. And now for this collider, we need to choose which game objects we want to check for overlap with. So from here, let's choose our player prefab. We'll do select. And now for our second object, we want this to be our platform group, but we want this to be our group property on this class. So if we save, let's come back to our browser. All right, if we refresh our browser, we'll see now when our player lands, it lands on our game object. And what's happening is the force from our player landing on that game object is now pushing our platform. In order to prevent that from happening, let's come back to our platform prefab. And under our arcade physics, when we have our body collision, we want to deselect pushable on our game object. Let's save. And now if we refresh, now we'll see when our player lands on our platform, it now stays there and our platform does not move. Now that our player is able to land on one of our platforms, we need to update our code so as soon as they land, our player is going to jump automatically, and then that way the player needs to navigate to our next platform. To make this change, we'll need to update the code in our level scene. So in our inspector, let's open up our level.js file. Alright, so for checking to see if our player is actually touching our platform, so we can actually jump, we need to do this in our update method. So our update method is going to be invoked once for each tick or update of our game loop, and this is where we'll do that check. All right, so to make this check, we need to have a reference to our actual player game object. Let's jump back over to our level scene. Let's update our variable name for our player prefab. Let's change this to be player. I'm just going to call this player. And then we'll want to update the scope on our variable. We're going to set it to equal class. So now when we save, if we come back to our level.js file, we'll see our code has now been updated in our editor create method to actually assign our player to this .player. So now that we have a reference to our variable, we can now reference that in our update method. Let's make a new variable, do const, and what we'll do is touching down. We're going to set that equal to this .player. We want to grab our player's physics body. Then we'll use touching, and we'll do down. And so what this will do is by calling this player.body, we're referencing our physics body. Touching allows us to check to see if that body's touching any other game objects. And then down allows us to specify which part of the physics body is actually touching another game object. So this would just be the bottom of our player's physics body. So now we're checking if we're touching down. We'll do if, we'll say if we're touching down. And so if we are touching down, now we want our player to jump. To have our player jump, we need to update our Y velocity. So we'll do this .player. Let's do set velocity, and we'll do Y. And so for our value, let's do -50 for the time being. Let's come back to our browser. Oh, so we have an issue with player prefab. Yes, so back in our level scene, in our collider, we were referencing player prefab. We just need to update our reference to reference our new variable. Let's save. Now if we come back to our code. So now we'll see when our player lands, we update our velocity so our player jumps up. Because our gravity is so strong, our player doesn't jump very high. All right, so if we come back to our code, let's update our player's velocity. Let's just do -200, refresh, and now we'll see our player jumps much higher. We'll see once our velocity reaches 0, our player is now pushed back down until it lands on the platform, and we start jumping again. So now, let's update our value be -350, and then that way our player should jump high enough to reach our next platform. So now if we save and refresh, now we'll see our player jumps out of our scene and we don't see, because our player didn't come back down, now it's landing on our other platform. So in order to address the issue where our player's off our screen, we actually need to have our camera follow our player. To do that, let's go into our create method in our level.js file. And to have our camera follow our player, we need to reference our main camera. So we're going to do this, we'll do our cameras, let's do main, and we're going to do start follow. Now we can provide which game object we want to follow. So we're going to do this .player. And so for round pixels, let's do false. And now for our other values, let's do 0.1, 1, and 0.1. And so these lerp values are just going to allow us to have a smooth camera transition as we're following our player. All right, so if we refresh our browser, we'll see now after the player lands on our platform, now our cameras actually follow them as they jump up. Now that we've added in our logic to have our player automatically jump when it lands on a platform, now we need to add in support for our player input. So then that way, as our player presses our left and right keys, we'll be able to move our player left and right across our scene. To make this change, let's go over to our level.scene file. Under our built-in blocks, let's go to input, and now we can add in our keyboard keys. Let's drag an instance into our scene. For our variable name, let's call this left keyboard key. And now for our key code, let's search for left. We'll select that key. We'll drag in another instance of our keyboard input. We'll change this to be right keyboard key. And now for our key code, let's search for right. We'll add that in. And now let's save, and we'll come to our level.js file. All right, so in our level.js file, we're gonna see we have our two new properties for our keyboard keys, our left and our right keys. And now what we can do in our update method is we can check to see if these keys are actually being pressed. And then if they are, we can update our player's velocity in our X direction. So down in our update method, let's add in another check. We're gonna do if. We're gonna say if our left keyboard key is down, so it's being held down right now, and if our player is not touching down, so if they're not on our platform, now we're going to allow our player to move around. To allow our player to move, we want to update our velocity. So let's copy this. We'll go ahead and paste it, but we want to change this to be our X velocity. For this, we want this to be a little bit slower. So we're going to do negative 150. And now we want to do the same thing, but if our right key is pressed down. So I'm going to copy this, and we're just going to do an else if block. And now if our right keyboard key is being held down, then we want to change it to be a positive value. And finally, if no key is being pressed, we want to reset this so our player's velocity in the X direction goes back to 0. All right, so we refresh our browser, we should now be able to use our left and right keys to move our player around. One thing to know is as we're jumping through our platforms, if we collide with the side, we're not able to actually move through our platform, and we're only able to do this when we jump through the bottom of our platform. To fix this, we need to update our collision checks on our platform. So similar to like what we did for our player, let's go into our platform prefab scene. All right, so we'll want to update our check for collisions. And so we'll want to check our up value, but we don't want to do down, left, or right. So now when the player lands on our platform, we're going to see if our player overlaps with the top of our physics body on our platform, and we'll ignore the other checks. Come back to our browser, let's save. We should now be able to have our player jump onto our platforms. And now we're able to collide with the sides and our player can move through it, but we're still be able to jump through them and land on the top. All right, so one other change we're gonna do for our player input is before our player actually lands on our platform, we're able to press the left and right keys and have our player move. We don't want our player to actually be able to move until they've successfully landed on the platform the first time and they do their first jump. This will allow us to have our player spawn further away from our first platform, and then that way the player won't lose automatically until they've actually started jumping. To make this change, let's come into our level.js file. We're gonna add a Boolean variable to keep track if we actually did our first jump or not. So under the section where we can add in our own code, let's add a new property to our class, and we're gonna call this first jump made. We're gonna set this equal to false by default. Let's come down to our create method, and we'll also reset that value. So that way if we restart our scene, we'll reinitialize it back to the default value. So now down in our update method, when we're doing our check if is touching down, now we'll also want to check to make sure we made our first jump. So we'll say, and this first jump made, and we'll do the same thing down here. So now we just need to update that value. So in our check for when we're touching down, we'll just add a check to say if not this first jump made. Now we want to set that value. So we'll do this, our first jump made will be set equal to true. So now back in our scene, let's just drag our player up some. Now if we save, we come back to our level. All right, if we refresh our browser, if we try moving our player before we land, we're not actually able to. Next, let's work on adding in our player animations. So if we go into our assets folder, let's do right click, we'll do new, let's do a new animations file. We'll just call this animations. We want that in our assets folder. Once our file's created, if we come to the top of our file, let's do add animation. And for our first animation, we'll do our player idle. All right, so then from our player atlas, let's choose our player idle animation frames. So we'll have idle 1, 2, 3, 4. So if we do shift click, we can select each frame. Let's do select. Now for our settings, let's update our frame rate so it's a little bit slower. We'll do 8, and we'll do -1 for our repeat, so our animation will repeat. Now let's add another animation. Now we'll do our player jump. For this, we'll do our player jump keys 1 through 6. For our frame rate, let's do 18, and we're going to do 0 for our repeat. So for our player jump animation, we'll have them initially jump, and then we'll have a spin animation we'll keep playing on repeat. So to add that spin animation, let's do a new one. We'll do player spin. Now for our spin animation, we're just going to do players jump 2 through 6. So let's select those frames. Let's do 16 for our frame rate, and this one we do want to repeat, so we'll keep it on -1. Finally, let's do our player hurt animation. So we'll do new, do player hurt. For this animation, we'll do player hurt 1 and 2. Let's select that. And now for our frame rate, let's do 8. And we don't want this to repeat, so we'll set it to 0. So now we have our new animations. We need to add this to our asset pack file. So if we click on our animations.json file, let's do import as animation. We'll add that to our asset pack. We'll save. So now to use our animations in our game, let's go to our player prefab scene. Let's choose our player. Let's update our default animation property here. So we're going to have it play an animation by default, and we'll start off with our player idle animation. Alright, so we want to test our various animations. We do this checkbox here. We can preview our animation through the editor. And then what we can do is if we update our animation key, our various animations should play based on our animation settings. Alright, so let's go back to our player idle animation. Next, let's update our code in our level.js file. So when our player jumps, we'll play our various animations for jumping and spinning. Alright, so after our player touches down, we'll play our animation. So let's do this. We'll do player. Let's do play. And so for our sprite, now we can provide our animation name. So this just needs to match our animation key. And so this will be player jump. And since our player jump animation doesn't play on repeat, we're going to listen for when this animation finishes, and then we'll start our player spin animation. And so to listen for that event, we need to use our event meta on our game object. So let's do this.player. We'll do once to register an event listener for one time. And now let's do our phaser. We'll do our animations, events, and we'll do our animation complete key. And then we'll provide our animation name. And we want to listen for our player jump animation completing. Now on our callback, now we want to play our spin animations. I'm just going to copy this here. Let's paste it. And we'll do player spin. Alright, so when we test our changes, let's come back to our browser. Alright, so if we refresh our browser, we'll see our players playing our idle animation until we land on our platform. And then we transition to our player jump and then go right into our player spin. Alright, so the last thing we'll do for our player is as we're moving our player around, when we go left and right, we would want our player to face that direction. So currently our player is always spinning to the right, and so we just need to update our flip property on our game object. To do that, let's go into our level.js file. We'll come down to our logic for we listen for our keyboard input, and so after we update our player's velocity, we'll update our flip x property. So if we're pressing the left key, we're going to do this.player, we're going to do set flip x, and we'll set this to be true, and if we're pressing the right key, then we'll set it to be false. Alright, so jump back to our level. Now if we test, when we have our player move left and right, they now face in that direction. Now that we have our player's animations, we're going to work on adding some walls to our level. So currently our player is able to move over as far as they want, both left and right, and this will cause the player to die since we don't spawn any objects over there. To keep our player within our space, we're going to add walls to our left and right sides of our game. To do this, let's come back to our code. Let's go into our prefab folder. Let's make a new prefab file, and we're going to call this wall prefab. So for our wall prefab object, we're going to use a TileSprite. So for our TileSprite, we're going to use this wall image here. And the reason we're doing a TileSprite is we want our wall to extend all the way up through our level, and as our player moves up, they would still see the wall. However, we don't want it to be static, and by making it a TileSprite, it's going to appear that our player is moving up through our level. So to make a TileSprite, we'll go into our texture built-in objects, and let's do a TileSprite for our base type. Now for our texture, we're going to choose our wall image. Let's update our positions. We're going to do 0, 0. And now we just need to update our size. So now for our size, we want this to be 32 pixels wide, and we need it to take up our whole screen, so we're going to do 176 pixels height. Now let's go ahead and position our game object in the top left-hand corner, so we'll update our origin, and we'll do 0, 0. Now that we have our wall prefab, let's open up our level scene, and let's add in our wall. Alright, so for our walls, let's make a new layer to organize all of our game objects that are tied to our level. So if we go into our built-in blocks, let's go under group, we'll add in a new layer. For our layer, let's call this our level layer. So now under our new layer, let's drag in an instance of our wall prefab. Let's position this at 0, 0. Alright, so let's update our variable name. We'll call this left wall TileSprite. For our display name, let's just do left wall. And let's drag in another instance and we'll do our right wall. So we'll do our right wall TileSprite. So I'm just going to copy our variable name from our other object. And we'll just update it to be right wall. So now for our right wall's position, for our X values, do 208, we'll do 0 for our Y. And now we need to flip it so it's facing the other direction. So if we come down to our flip property, let's do flip X. Now let's save. So now for our walls, we'll want our player to appear in front of them. So let's make a new layer for our player and we'll place that on top of our level layer. So let's add in our new layer. For this, we're going to call it player layer. All right, so let's go ahead and move our player game object into our layer. If we do right click, we'll do parent, we'll do move to parent. Let's choose our player layer. And then finally, let's move our platform group above our other layers. So we right click on our group, let's do layout. We're going to do sort, we'll do move up, and we'll move it up one more time. All right, so if we save our changes, let's come back to our browser. We'll see when our browser refreshes, we can see our walls are being added, but they're not repeating across their level. To fix that, we need to update our scroll factor for our tile sprites. So let's go into our wall prefab.js file. Let's go to our constructor, where we can add our custom code. All right, if we refresh our browser, we can see our walls are visible to our player, but we need to move over to see our right wall. And so we're going to update our player's position so we start in the middle. And another issue we need to fix is our tile sprite is not repeating across our level. To fix that, we need to update our scroll factor on our tile sprite. So let's jump back over to our code. Let's go into our wall prefab.js file. So up in the constructor, we can add in our custom code. Let's update our scroll factor. So we're going to do this. We'll do set scroll factor. And for both our X and Y value, we'll set it to 0. Now to update our player's position, let's come into our level. Let's right click on our player. Let's do layout. We'll do align to border. Let's do center. We're going to copy that X value. Let's save. Let's go into our platform group prefab. We're going to update our default X value position for our group. And let's do 120. All right, so if we refresh our browser, we're going to see our walls are now visible to our player. And now we're in the center of our screen. There's a few things we're going to want to fix. The first is our player can't actually reach our wall. And so as our player moves over, we're updating our camera's position. And because we update our scroll factor for our walls, our player can't actually reach them. We'll need to update our camera so we don't actually move it left and right as our player stays within this area. And the second thing we want to fix is as our player is moving up, we want our tile sprite to be animated. So that actually looks like we're progressing through our level. To make these changes, let's go back to our code. All right, so we'll start off by updating our walls to be animated. And for our tile sprites, in order for them to appear to be animated, we need to update their tile positioning. What that's going to do is it's going to have this tile here, our texture, appear to be moving down, but our game object's position will actually stay in place. So for this change, we'll want to do this for both our left and right walls. And so let's make a new list to keep track of these game objects. So we drag our list in. Let's update our variable name. We'll do moving level tile sprites. And so we're making this generic because we'll also reuse this logic once we add in our background and our foreground images, and we want to animate those as well. So now that we have our list, let's choose our left and right game objects. Let's go into our list in our inspector, and we'll add it to our new list. Go back over to our level.js file, we'll see our new properties available on our class. So let's come down to our update method. After we do our logic for where we handle our player input, this is where we'll update our sprites. So we'll want to iterate through our array. So let's do this. We'll do our moving level tile sprites. We'll do for each, and now for each of our tile sprites, we want to update our tile position. To do that, we just do our tile sprite. Now we'll do tile position Y. We're going to set it equal to our player's Y position. And now we're going to multiply it by 0.2. So now if we come back to our level, or if we refresh our browser, as our player moves up through our level, we'll see our tile sprites are now animated. So one other change we're going to do is we're going to update our prefab so we can have a different offset for one of our game objects. And then that way our pattern is not repeating on both the left and right sides. To do this, let's go into our wall prefab scene. Let's add a new property to our prefab. So we'll do new property. Let's make this a number. Now for our property name, let's do tile offset Y. We'll leave our default value for 0. So now use our new property. Let's jump over to our level scene, and we'll want to update our right wall prefab. So over in our inspector, if we expand our prefab properties, let's update our tile offset Y, and let's do a negative 120. All right, let's jump over to our level.js file. We'll go to our code where we're updating our tile's position. Now let's update this to include that tile offset. So we're going to do our tile sprite, and let's do our tile offset Y. Let's save. If we come back to our browser, we refresh, we'll see now our right wall is animated, and it's in a different position than our left wall. Now to fix the issue with our player not being able to reach our walls, we need to update our camera's position. To do this, we want to define what's called a dead zone. And what the dead zone does, it allows us to define an area, and as long as the object that camera is following is in that area, we won't update our camera's position. Once the game object leaves that defined area, then the camera will start updating. We'll come back to our code. So up where we have our camera start following our player, this is where we'll define our dead zone. So we're going to do this, our cameras. Let's reference our main camera, and we'll do set dead zone. Now for this, we want to do the width of our level. So we're going to do this.scale, and then we'll do our width property. Now for our height, we'll leave that alone. So then that way, as our player moves up through our level, it'll get updated. So now as our player moves around, we'll see our camera doesn't move left and right, but it still moves up as we move up through our level. So now to prevent our player from moving through our walls, we need to give our tile sprites a physics body. So we come back to our code. Let's go into our wall prefab. Up under constructor, down below our set scroll factor, let's add in our physics body. So for this, we're going to need to reference our scene. And so we're going to do const, we'll do underscore scene is going to equal to this.scene. I'm going to add in our type real quick so we have our IntelliSense. And so for our type, this will be a phaser scene. So now with our scene, we can do our physics. We'll do our world, and now we want to do enable, and we'll provide our game object that we want it to add a body to. So we'll do this. So now that we have our physics body on our tile sprite, we want to update it so it's not movable, and we want to disable our gravity, kind of like what we did for our platforms. So let's reference our body. We'll do set immovable. We're going to set this to be true. Now we'll do set allow gravity. We're going to set that to be false. All right, so if we save, let's come back to our level. All right, so if we refresh, we'll see our two walls now have our bodies, and we'll want to update their size, so then that way they match where our wall ends. To make that change, back in our code, let's call set size. We'll do 16 pixels, and we'll use the full height of our game object. And now we'll call set offset, and we're going to do 0, 0 to reset our body's position. Now if we save, if we refresh, we'll see now our bodies are updated. So a few things we need to fix is as we move up through our level, we need to have our bodies follow our player, and we need to update our position of our right wall body. To make these changes, let's come back to our code. Let's go into our level scene. So to update our bodies on our walls, we're going to want to keep track of our walls individually from our tile sprites that we want to update. To easily do this, we can add another array or list to keep track of these game objects. So from our built-in blocks, let's go under our group. Let's add in a new list. For our list, we're just going to call this walls. So now for our two wall prefabs, let's select them. Let's add them to our new list. All right, so we come back to our level.js file. We'll come down to our update method after we update our offset. And now this is where we'll want to update our bodies. So for this, I'm just going to copy this block of code here, and we'll update our list reference. And so we're going to do this.walls. We'll do for each. So we'll have our tile sprite, but instead of updating our tile's position, we want to update our tile sprite's body. So we're going to do tile sprite. Let's do our body. We'll do set offset. We're going to do 0. And now we need to update our Y value. And we're going to base that on where our camera is currently at. So let's do our cameras. Let's do our main. We're going to do our world view. And let's do our Y value. What this will do is this is going to grab the view of what our camera can currently see in our world. And it's going to grab that Y value. And by using that Y value, we'll see now as our player moves, because our camera is moving, that's now causing our two wall game objects to move with our player. So now to fix the issue with our wall on our right-hand side, we need to update our offset. To do that, back in our code, let's add a check to see if our flip X is set to true. And so we'll do if our tile sprite flip X is true, then we'll do the same code, but we'll also update our X value. So for this, we'll update our offset to be 16. And let's just wrap this other block inside our else. Let's save, we come back to our level. All right, so if we refresh our browser, we'll see our right wall's position is now updated. So now for our two wall game objects, we just need to add a collider so our player actually collides with our walls. To do that, let's come back to our level scene. Let's go down to our built-in blocks. Let's go under arcade. We'll add in a new collider. So for this collider, let's update our variable name. We'll do player with walls collider. So now for our first object, let's choose our player. So go into our player layer, we'll grab player. For our second object, let's do our walls list, and then that way it's going to apply for both of our prefab game objects. So if we save, let's come back to our browser. Now, when our player moves, it collides with our wall game object, and our player is not able to actually move through it. Now that we have our logic in place for allowing our player to collide with our walls, we need to revisit our logic for our platforms. So currently we have our 5 platforms, and once our player reaches the top, they're not able to progress any further. So for our group, we need to work on respawning our game objects once they leave a certain area of our game. And so what this will look like is after our player jumps on one of our platforms, they're going to move further up throughout our level, and our platforms will keep moving down. As our player keeps progressing, our platforms will get further and further away from what's currently in view for our game. So after a certain point, we'll want to respawn this platform back above the player, so that way as they keep moving up, they'll eventually be able to jump to the next one. So now to figure out when one of our game objects needs to be respawned, we'll need to make use of our camera and its current position. So since our camera's following our player, we can use our camera's offset to figure out where it's at currently in our world coordinates. And if our platform is greater than a certain distance, then we know it's eligible to be respawned. And so now to add in this logic, let's go into our platform group prefab.js file. And inside here, this is where we'll keep track of when we need to respawn our platforms. To do this, we'll add in our update method, and then we'll call this method from our level scene. So inside this method, the first thing we'll do is we need to grab our camera's current position. So for this, we'll be using our scroll y property. So let's do const, we'll do scroll y will be equal to this, our scene that our game object belongs to, our cameras. We'll grab our main camera, and let's do our scroll y. Next, we need to define our max distance, so how far away a platform can be from this position before we respawn it. For this, it's going to be a static value, so we don't want to define it in our update method. We'll define that up here in our constructor. So let's make a new property for our class. I'm just going to copy our group definition here. We're going to paste that. I'm just going to change this to be max platform distance, and we'll just change our type to be a number. Now we'll want to define this in our constructor. So after we do our platforms, let's do this. We'll do our max platform distance. It's going to be equal to our scene. We'll do our scale property. Let's do our height. So now for our value, we're going to use our scene, our scale, and then our height property, and we'll multiply it by 3. So basically, let's take the height of our game and multiply it by 3, and once our platform's that far away from our camera's view, then we'll respawn it. So next, we'll need to keep track of which platforms we actually need to move, and so for this, we'll need to grab our children from our group game object. So first, we'll grab our children, so we'll do const, we'll do children, it's going to be equal to this.group, and we'll do get children. So this will give us an array of our game objects, and now we'll do const, and we'll say children to move. We'll set that equal to an empty array for the time being. So now we need to iterate through all of our children. So we'll do children, we'll do for each. So for each child game object, we want to check their y position. So if the child.y is greater than or equal to our current scroll y value plus that max distance, then they're eligible to be respawned. So we'll do our children to move. We'll do push, and we'll add in our child game object. So now that we have our array of game objects we need to move, we need to figure out which y position to position them in. Alright, so to respawn our game objects, we'll be making use of our scroll y value for our camera. We'll use that as a starting point, and we'll subtract some distance from this in order to dynamically generate our platform outside the view of our camera. So we'll do a random x value and a random y value for positioning that platform above our camera. Now, since we have an array of game objects we need to position, we're going to go ahead and stack them and position them little by little based on the number we need to respawn. So then that way our game objects will be spaced out, just like what we did when we initially spawned them. So to add in this logic, let's come back to our code. First, we'll need to keep track of the distance that we need to spawn our game objects away from our starting position. For this, we'll make a new variable. We'll do children to move y offset. We're going to set that equal to 0. Now we want to iterate through our array. I'm just going to copy this here. We'll paste it here. But we want to iterate through our children to move array. So now for each of our game objects, we'll want to update our x position first. So we're going to do child.x will be equal to, we're just going to copy the same logic when we spawn our group here. So let's paste that here. Next, we need to update our child's y value. So for our child's y value, this is going to be equal to our scroll y, and we want to subtract our offset here. So now for updating our child to move y offset, we're just going to use that value, and we're going to increment it by a random value. So like what we did for our x value, we choose a random here. We're just going to copy this. We'll paste that down here. But now for our position, we want to be between 10 and 40 pixels. All right, so we save. Let's go over to our level.js file. And now we need to call the update method on our platform group prefab. So if we go into our level scene, let's go into our platform group prefab. We're going to update our scope to be on our class, come into our level.js file. Now at the bottom of our update method, we should be able to do this, our platform group prefab, we should be able to call update. All right, now if we come back to our browser, we refresh. Oh, looks like we have an issue. Oh, yep, it shouldn't be max distance. This actually needs to be this dot our max platform distance. Now if we come back to our browser, all right, so we refresh our browser. Now as we move up through our level, our platform should start respawning. And so we'll see our distance between each platform will start to be more variable since we're using that random value. Nice. Now that we have our logic working for respawning our platforms, we need to add in logic for once the player drops below our lowest platform and then transition to our game over state. So for this, we'll need to keep track of which platform is currently in the lowest position, and then once our player's Y position drops below that platform, that'll be our trigger to know that our game is over. To make this change, let's go into our platform group prefab.js file. When we iterate over our child game objects, this is where we'll add in our check to see which platform is currently in the lowest position. We'll then need to expose that value as a property on this prefab so we can use it in our level.js file to check if our player's below that position. To get started, let's copy our max platform distance value here. We'll add that property to our class. And now let's update our property name. We'll do bottommost platform Y position. Let's go up into our constructor, we'll add in our default value. So we'll do this, we'll do our bottommost Y position, we'll set it equal to 0. So now down our update method, let's start off by updating our value to be equal to the Y position of our first child game object. We'll reference our children array, we'll grab our first index, and we'll grab our Y value. So now down in our update method, we'll add a check to see if our child's Y value, if this is greater than our bottommost platform Y position, then we want to go ahead and update that position to be equal to this child's Y value. Alright, so with that change, our property should now have the Y value of our lowest platform. So now back in our level.js file, we're going to need a way to keep track if our game's actually over. So let's add a new property to our class. And so we'll come up to where we can have our custom code. Let's do is game over, and we'll have a default value of false. Let's go into our create method. Let's set up our value, so reinitialize it. So we'll do is game over is equal to false. And now down in our update method, alright, so after we do our checks for our tile sprites, this is now where we'll check to see our player's position. So to get started, first we're going to see if our game's currently over. So if our game is over, then we just want to return early from our update method and not make any other changes. And so if our game is not over, now we need to check our player's Y position and compare it against our platform. So we'll do if this, our player's Y position. So if our player's Y position is greater than our platform group prefab, our bottommost platform Y position, and we'll add in 50 just so that way we're below the platform and not just even with it. Then we want to set our game to be over. So we're going to do this, we'll do is game over, we're going to set it equal to true. Alright, so then when our game is over, we'll want to play our animation for our player being hurt. So we'll do this dot player, we'll do play, and let's do our player hurt animation. Alright, so if we save our changes, let's come over to our browser and we'll test. Alright, so we refresh our browser. Oh, it looks like we have a few issues. And so right after our player spawns, they automatically die. And then after we're in our game over, we can still move our player around. So what's happening is first for our player being able to move, we need to update our if statements here to make sure we only process our input if the game's not actually over. So we're just going to add a safeguard, do if this game is not over, now we want to process our input. So we'll add that to each of our checks here. Alright, so next for the issue tied to our player dying, as soon as we spawn, what's happening is we set our default value for our bottommost platform position to be 0, and our player's position starts greater than that right away when our game starts. Because currently in our update, we don't call our platform group prefab update until the very bottom of our update loop here. So to address this, we need to move our player up above our scene so that way it starts in the negative value, and we'll also want to update the starting position of our first platform. So for our changes here, let's update our player to start at -84 for our Y value. Next, in our platform group prefab, let's update our starting Y value for our platform, and we'll start at 0. Since we're starting at 0, we'll remove our increment of 150 to our Y value here. So now if we come back over to our level, let's save and refresh, we'll see now when our player spawns, we're back in our idle position, and we're still able to play our game and move up through our platforms. However, now when we fall, as soon as we drop below that bottommost platform, our player now goes into our hurt animation, and then our player keeps falling down. So what we want to do is we want to start slowing down our player once they die. So if we come into our level.js file, when we do our check if we're in game over, let's update our player's velocity. So for this, we're going to do this, we'll do our player, we'll do set velocity, and we'll do our set Y velocity, and let's set this to 15, so we start slowing our player down. We'll also make the same change after we do our animation update here. Let's save, and now if we come back to our game, alright, so now if our player drops below our bottommost platform, they'll start slowing down, and we see our animation play for our player being hurt. So now that we have our logic in place for when the game should be over, we're going to spruce up our player dying animation. And we're going to add some special effects to have our player fade away once they die. So for this, we'll be making use of the Phaser FX wipe controller that's available on our game objects when we have a WebGL game. This controller allows us to use some special effects using WebGL, and we can create effects like this where we'll have our game object disappear. So to do this, let's jump back into our code. And to create these special effects, let's make a new variable, do const. We'll do wipe FX. We're going to set it equal to this.player. We're going to do post FX, and then we're going to do add wipe. So now for arguments, we'll do 0.1, 0, and 1. All right, so what we're doing here is we're using the postFX component on our game object, which has a number of built-in effects that we can use for our objects. These effects can either be applied to our game object, either post or pre-rendering, and it uses WebGL to create some really cool effects. For the wipe, and so for our add wipe method, we can provide a variety of arguments to control the direction and the width of the wipe that we want to apply to our game object. And so that's what we're doing with our arguments here. So now that we have our special effect, in order for us to create that animation, we need to add a tween to modify the overall progress of our special effect. So for this, we're just going to do this.tweens.add, and now we need to provide our tween configuration. So for our target, we want this to be our special effects. We'll do our wipe FX. So now for the property we want to target our progress property. We want to set that to 1. For our duration, for how long our tween will last, let's do 3 seconds. And then for our callback, we'll add in our onComplete. So now in our callback, let's disable our player's body so it stops moving. And so we'll do this.player body. We'll do enable. We're going to set it equal to false. And then just do a console log. We'll say game over. And so now this is where we'll transition to our game over scene. But for the time being, we won't do that. All right, so to test our changes, let's come back to our game. And if we have our player fall past the bottom platform, we'll see now we have that special effect taking place. Next up for our game, our next feature we want to implement is we want to add in a score mechanic. And so as our player progresses up through our level, the higher they go, we want to increase their score. And if the player falls back down, we don't want to increment our score, and we want to do it based on the height that the player's reached in our game. So to add this in, we'll be making a new phaser scene that will be a UI layer that'll sit on top of our current scene that'll display our score. So we jump back to our project. Let's go ahead and create a brand new scene. So if we go into our source folder, under scenes, let's make a new scene file. For this, we're just going to call it UI. Let's do create. So now in our new scene, we need to add in a text game object that's going to represent our score. So under our built-in blocks, let's go into string. We'll drag in our text game object. So now for our variable name, let's do score text game object. And for our display name, we'll just do score. So now for positioning our game object, we want it to be in the top right-hand corner. So for our X value, let's do 235. And for our Y value, we'll do 5. So now for aligning our game object, we want it to be on the right-hand side. So we're going to move our origin to be on the right-hand side of our game object. So for our X value, let's update this to be 1, and we'll leave our Y value at 0. Now for our default text, let's just update this to be 0. Now for our font family, let's choose our Press Start 2P font that we previously loaded in. All right, so now that we have our text game object, we need a way to update our value. So let's open up our UI.js file, and let's add a method to our class that we'll be able to invoke from our level scene. So for this new method, let's call it update score text. So for our method, we'll need one argument, so we'll have text, and so this will be the text that we want to set to our UI. All right, now for this, we'll need to be able to update our score text game object. So if we come back into our scene, let's update our scope. We're going to change it to be class. All right, now if we come back into our UI.js file, now we should be able to do this .score text game object. We'll call set text to update our text string, and then we'll pass in our text. So now that we have our new scene, we need to update our phaser configuration to include our scene. So let's go into our main.js file. So at the top of our file, let's copy one of our imports, and we'll want to import our UI scene. Let's update our scene name, and now down in our configuration, let's copy our level here. We'll paste that. Let's do UI. And we'll do UI. Now that we've added our scene to our game configuration, we need to actually start our UI scene once we start playing our game. To do this, we'll be making use of a script node. So previously, when we downloaded our assets, there was a script nodes folder. We'll need to add that to our project now. So if we click on our source folder, over in our inspector, let's drag over our script nodes folder into our add files. So now what this should do is now we should have this new script nodes folder that has a variety of scripts we'll be using for our project. So now if we go into our level scene, all right, so to launch our UI scene, we want to wait until our level scene first starts, and then once it's available and running, we want to trigger an action to launch our UI scene so we can see our score. To do this, when we create a scene with phaser editor, one of the things that happens is we emit out this scene awake event. We can then listen for this event in one of our scripts and then use that to trigger other actions. And so to do this, in our script notes folder, under our utils folder, we have this script node called onAwake action script. What this does is it listens for that awake event, and then we can trigger other scripts based on when this event happens. And so to see an example of this in our outline, if we right click on our scene folder, let's do add script to add a script to the root of our scene, and we'll do add script. So now here we'll go into our utils folder, we'll do our onAwake action script. So now what will happen is as soon as our scene starts and that awake event is emitted, this script will trigger. So now we can add a child script to this to launch our UI scene. So for that, under our scene folder, we have a bunch of utility scripts that will allow us to start and stop scenes and then launch scenes in parallel to our existing scene. And so to do that, we need to add a child script to our onAwake action script here. To do that, we can use our shortcut key, U, or if you right click, you can do scripting and do add script. So now we'll do scene, and we want to do launch scene action script. So if we open up that launch scene action script real quick, and so in the script, all we're doing is we're referencing our scene manager, and then we're calling the launch method to launch another scene in parallel to our existing scene, and we base that on a property we provide to this script. So to provide that property over on our inspector, if we go into our launch scene action script, if we choose our scene key, let's choose our UI scene. So now if we save, come back to our game, we should be able to test. So see right away, we can now see our score up in our top right-hand corner. So now we have our score visible in our level scene, we now need to implement our actual score mechanic. For this, we'll need to add some properties to our game scene to keep track of our current score and to keep track of the max height that our player has reached in our game. To figure out our max height, we'll need to use our player's current starting Y value and compare that to their current position in our update method. And so to start making these changes, let's come back to our code. In our level.js file, we want to add a few properties to our class. Let's start off with our current score. So we're going to do current score. We're going to set that equal to 0. So now we need to add in properties to keep track of our height. So let's add in max height. And so we'll set that to 0. And now we'll do our starting max height. And we'll set that equal to 0. All right, so for all these properties, let's reset those values in our create method. So when we restart our scene, we'll be back to 0. So we'll do this.current score. We'll set equal to 0. I'm going to copy that line and just paste it twice. So now we'll do our max height, and we'll do our starting max height. So now down in our update method, this is where we'll want to update our score. All right, so to calculate the distance our player's actually moved, we'll be making use of our player's physics body. So on our physics body, we can grab the bottom Y value of our game object, and we'll use that as our starting position. So then as our player moves up through our level, we'll check that Y value, and as that distance grows, we'll use that to increment our score. So since we're moving up in our level, we're really moving in the negative direction. And so for the value we calculate, we'll want to use our absolute value so we have a positive number. So to do this calculation, let's make a new variable. We'll do const, we'll do distance is going to be equal to math.floor. Now we want our absolute value, and we'll do this.player.body, and we want to do the bottom of our body. So now this will give us our current Y position for where our player is currently at. All right, so now for actually updating our score, in our update method, we'll come down below our safeguard for when our game is over. And so we're going to do a check. We'll do if our current distance is greater than our max height, then we want to increment our score. So we'll start off by resetting our max height to our current distance. Then we want to update our current score. All right, so then for our current score, we're going to want to take our max height and subtract our starting height to get this value. So now that we have our score, we can update our UI scene. To update our UI scene, we need to grab it from our scene manager. So we'll do this.scene, we'll do get. Now we need to provide the key of the scene, so UI, and now we can call our method on our scene. So we're going to do update score text, and we can provide it our current score. So one last change before we test is we need to actually set our starting max height for our game. To do that, we're going to come to our logic where we do our check to see if this was the first jump that was made. And once our player touches down on our platform, that will be our trigger to set our starting max height. So we'll do this, we'll do starting max height will be equal to our current distance. All right, so if we save our changes, we come back to our browser, we refresh, we show the test. Oh, we have an issue. Yes, we need to update score text, not update score. All right, so now if we come back and test, all right, so after we refresh, so we'll see that our score doesn't start at 0, so we'll need to fix that. But as our player moves up through our level, we'll see our scores being updated in real time. So for our score, we're climbing quite high very fast. So what we're going to do is we're going to divide this by 10 just to have a nicer number. So if we come back to our code, let's take this value and we'll divide it by 10. So if we save, let's come back to our level. Alright, so as we refresh our browser, we'll see now our score is much smaller, but now we need to deal with our decimal. So let's come back to our code and let's do math.floor to round out our integer. So now if we save, we'll do one more test. Alright, much better. So now we just need to fix the issue where we start off at height 6 when our scene starts. To fix our issue with our starting score, we just need to add a safeguard here. So before we actually update our current score, we want to make sure our player has actually landed on the platform and we've made our first jump. So for that, let's just copy this line here. We'll come down to our code. So now if we save, alright, so if we refresh, we'll see our score starts at 0, and right after our player lands, we start incrementing our score. Nice. Now that our score mechanic's working, we're going to work on increasing the difficulty for our game. So currently as our player moves up through our level, we increase their score, but nothing else changes in our game, and so our gameplay becomes a little bit stale. To make it a little more exciting, once our player reaches a certain score threshold, we're going to go ahead and introduce a moving platform. So our platform is going to start moving around our scene left and right, and we're going to make this random so that way not all of our platforms move. It'll be more like a platform type when we spawn our platform in our level. And so for this change, all we need to do is update our platforms to have an X velocity, so then that way they can move left and right through our level. So to make this change, let's come back to our code. Let's open up our platform prefab.js file. So to enable our platforms for movement, we just need to update our X velocity. But we'll also need to keep track of where our platform's currently at, and then that way as we move our platforms back and forth, we'll limit where our platform can actually move to. We'll want to have a minimum X value our platform can move to, and a maximum X value that our platform can move to. Alright, so to get started, we'll need to add some properties to our class. So first, let's do our horizontal velocity. Next, let's add in properties for our min and max X position values. So we'll do min X position, and let's do max X position. So now we'll want to initialize these values. Let's come up to our constructor. And so we'll start with our horizontal velocity. We'll set that equal to 0. Let's just copy that line. We'll paste it twice and we'll update our two other values. And so we'll have our min X position and then our max X position. So now for our horizontal velocity, let's set this to be 50. And then so for our X positions, we'll just want to match the values that we're using in our prefab group. And so we'll set this to be 10 for our min value and 200 for our max, and we'll do 200 for our max value. And now to actually have our game object move, we'll need to update our game object's body's velocity. And so to do that, we'll do this. We'll do body. We'll do our velocity. We want to do our X velocity, and we're going to set it equal to our horizontal velocity. So now if we come back to our browser, if we refresh, we should see right away our platforms start moving in our game. So now we'll need to add in our logic, so then that way once they reach that max position, we'll reset our velocity in the other direction. To make that change, we'll want to add the update method to our game object. So let's do update. Let's grab a reference to our body's velocity. So we'll do const, we'll do velocity, and we're going to set it equal to this, our body, and then our velocity. Now we want to check our game object's X position, and if it's below our min value, we want our velocity to be in the positive direction. If it's above our max value, we want it to go in the negative direction. So we'll do if this.x is less than this.min X position, then we'll update our velocity.x to be equal to our horizontal velocity, and then we'll do else if this.x is greater than this.max X position. Now we want to do in the negative direction. So we'll copy this here, and now we'll want to multiply this by -1. So now we just need to call our update method from our group. So if we go into our platform group prefab.js file, and when we create our phaser group, one of the configuration settings we can set is we can set run child update. When we set this value to be true, Phaser will automatically handle calling the update method on our child game objects that exist in this group. By default, this is set to false, and so now by pressing true here, this should automatically invoke our update method. So now if we save our changes, let's come over to our browser, we should be able to test. Alright, so we refresh our browser, we'll see now as soon as our platforms either reach our min or max values, we reset our velocity and our platform starts moving in our other direction. Now that we have our logic for our platforms being able to move, we now need to add in a toggle to allow us to turn this on and off, so then that way when our game first starts, our platforms are not moving, and we'll only start moving them once our player reaches that certain height. To make this change, let's add a new property to our class, and we're going to call this enable platform movement. We'll come onto our constructor, let's set our default value to be false, so we'll do this.enable platform movement, and we'll set equal to false. And now we'll want to remove our code where we update our body's X velocity. Then down in our update method, we're going to add a safeguard to see if our enable platform movement is set to false, and if it is, we'll just return early. So we'll do enable platform movement. If it's not true, we'll just do return. And now we just need some methods to allow us to turn this on and off. And now we just need a mechanism to turn this on and off. So let's add two methods to our class. We'll do start platform movement, and then we'll do stop platform movement. So I'm just going to copy this here. Let's paste it, and we'll do stop. So now when we call start platform movement, this is where we'll want to do our code for updating a body's x velocity. And so we'll do this .body.velocity.x will be equal to our horizontal velocity. And then we'll want to update our enable platform movement value. So we'll do this, enable platform movement. Let's do true. And now we'll want to do the inverse of this when we call stop platform movement. So we'll set this equal to false, and we'll just reset this to 0 when we stop our platform. All right, so come back to our browser, we should be able to test our change. So now our platform should spawn and they should no longer be moving. So now we just need to call our start and stop methods once we want to actually enable our platform movement. So if we come back to our code, let's open up our platform group prefab.js file. All right, so in our platform group prefab, we're going to want to add a flag to indicate if we should actually enable our moving platforms or not. So for this, let's come to where we can add in our custom properties. I'm going to copy our property here. Let's paste it. And for our property name, let's call this enable moving platforms. We'll start off with this set to false by default. I'm going to set our type to be a Boolean. So now down in our update method, once we have our array of children that we need to update their positions for, this is what we'll add in that check. So let's add in our check to see if we should enable our platform movement. So we'll do this, we'll do enable moving platforms. And if this is set to true, now we want to randomly determine if we should enable our platform movement. For this, we'll just use our built-in phaser utilities. So we'll do if, we'll do phaser.math.random, and we'll do between, and we'll do 0 and 1. So like we're flipping a coin. And if this value is equal to 1, we'll enable our platform movement. Otherwise, we'll disable it. So now on our game object, we'll just want to call our two methods here. So we have our start platform movement and stop platform movement. So we're going to do child.startPlatformMovement. Otherwise, we want to call stop. So I'm going to copy this here, we'll paste it, and let's just copy our method name, and we'll paste it here. So now if we want to test our changes, let's set this to be true by default. If we come into our level, if we start our game, we'll see that our platforms are not moving by default, but as we move up through our level, we should now start seeing platforms starting to spawn where some of them are moving and some of them are not. Alright, so now we just need to add in our logic for enabling this flag. For this, let's come back to our level.js file. Alright, so now what we want to do in our level is once we reach a certain score threshold, we'll want to toggle our flag on our group prefab to be true. Now for this, we only want to do that update one time, and so we'll want to introduce a new property to keep track of this. And so we're going to add a property to keep track of our overall level or our difficulty level for our game. So to do that, let's add in a new property to our class. So I'm going to copy this here, we'll paste it, and we're just going to do level. And we're going to set this to be 0 by default. Let's update our default value in our create method. And so we'll do level will be equal to 0. So now down where we calculate our score and we update our UI, now we'll add in our check to see if we've reached that threshold, and then we'll enable our feature. So let's do if this.level is equal to 0, and we'll do our current score. And let's just say if we reach greater than 200, now we want to enable that flag. So we're going to reference our platform group prefab, and now we want to call enable moving platforms. We're going to set that equal to true. Now what should happen is if we come back to our game, we should see that our platforms are not moving by default. And so once we reach 200, we should start to see our platforms moving in our game. All right, so now we can see some of our platforms are starting to move. Nice. Alright, so with that last change, that actually wraps up our core features for our game. So now we're going to work on sprucing up our game by adding in things like our background for our level. We're going to add in a game over scene where we'll display our score to our player, and the player will be able to click to restart the game. And we'll also add in a nice title screen that will show to the player before they start playing. Alright, and so to start with, we'll work on our background and our foreground for our level. For this, let's jump back over to our editor. Alright, the background for our level is going to consist of two different tile sprites. We'll have this background here, and then our foreground image here. So for both of these, let's create some new prefabs. Let's go into our prefabs folder. We'll start off with our background. So let's do right click, we'll do new, let's do prefab file. We're going to call this background prefab. So now for our starting blocks, let's go into our texture and we'll do in our TileSprite. For our texture, let's choose our background. All right, so now for our size, we want to take up our whole level. So for our width, we'll do 240 and we'll do 176 for our Y. Let's update our origin to be in our top left-hand corner. Then finally, let's update our starting position. We'll do 0, 0. Let's open up our background prefab.js file, and we'll want to update our scroll factor so our game object doesn't move. So let's open up our wall prefab.js real quick. We're going to copy this line of code here for our scroll factor. Let's come back into our background prefab, and in our constructor, we add our custom code. Let's set that value. So now let's create a prefab for our foreground. So we'll do new, let's do new prefab file, and we'll do foreground prefab. Let's add in our block for our TileSprite. And so for our texture, let's do this middle ground image here. We'll update our values. Origin will be 0, 0, position 0, 0. Now for our size, we'll do 240 by 176. Let's save. Let's go into our JS file for this. Let's go into our constructor and let's paste in our code for setting our scroll factor to 0. So now that we have our prefabs, I'm going to close those files. I'm going to go into our level scene and let's drag in some instances of our prefabs. So we'll come to our scene. Let's go to our level layer. Let's drag in our background first. We'll update our position to be 0, 0. And now let's drag in our foreground on top of our background and we'll do 0, 0 for position. So now for both of these, we want to move them below our walls. So we'll do right click. Let's do layout, sort, and we'll do move to bottom. Now let's save. So now for our foreground, we're going to want to add this to our list for our tile sprites that we move when the player moves throughout our level. So let's select that. Let's save. Oh, so it looks like we have an issue. Let's come back to our code. Go into our level.js file. So when we're doing our update for our tile position Y, we're currently using that tile offset Y position that we added to our wall prefab. Since this does not exist in our other prefabs, this is messing up our code here. And so for this, we're just going to want to add a fallback value. So we're going to wrap this in parentheses and we'll do we'll do 0. So now if we save, let's come back to our browser. Much better. So now we can see our level and our foreground in our game. All right, so now we have our nice background for our game. Our styling on our background of our page is really standing out. To fix this and to have it fit with the theme of our game, we're also going to use our background image as the background on our web page. And we'll just add some minor styling so it looks really nice. So if we come back to our code, let's open up our index.html page. And so in our styling here, let's remove our background property for where we're setting our color. And we're going to add a background image. So let's do background, we'll do image. For this, we want to do a URL, and now we want to do the URL to where our background is stored. And so we're going to do assets. Let's do background. Let's do our middle ground, no fungus, .png. Let's update our background image size. So we're going to do background, we'll do size, do 100%, and we'll do auto. And now we're going to modify our color, so then that way it's a little bit darker and it's a little bit more transparent. So let's do our background, we'll do color, let's do RGBA. So our red, green, blue, alpha, and we're going to do black. So we're going to do 0, 0, 0, and we'll do 0.8 for our alpha. And now let's do our background, our blend mode, and set this to darken. So let's save. And now if we come back over to our browser, all right, so if we refresh our browser, we'll see now instead of our basic color, we now have our background image, and it fits with the overall theme of our game. So now we've implemented our background for our game, we're going to work on implementing our game over scene. So once our game object for our player fades away, we're going to have our scene fade out, and that's going to transition to a new phaser scene, and this is going to show the text game over with the score that the player received. After a few seconds, this scene will fade away, and it's going to allow the player to play our game again. To make these changes, let's make a new phaser scene in our project. So under our scenes folder, we'll do right click, let's do new scene file. For this, we'll call this game over. So in the scene, we'll show the text game over as well as the score the player received. So for these, let's add in some text game objects. So we'll drag in one text game object. For this, let's call our game over text game object. Now for our positioning, for our X value, let's do 30 and we'll do 39 for our Y. Let's come down to our text content. We'll update this to say game over. We'll update our font family. Let's use our press start 2P. And now so for our font size, let's update this to be 20 pixels. All right, so let's make a copy of that game object. So if we right click on the object, we can go down to edit and we can do copy and paste, or we can use our shortcuts. So now with our other text game object, let's update our variable name. For this, it'll be our score text game object. For our display name, we'll do score. And now for our styling, we'll make this a little bit smaller than our other text. So let's do 10 pixels. And for our positioning, let's do 95 for our X. And we'll do 97 for our Y. And then for our text content, we'll say score. All right, so let's copy that game object. We'll paste it. And now this will be our actual score value. So for our variable name, we'll do our score value text game object. Our display name, we'll do score value. Now for our positioning, let's do 120 for our X, and we'll do 122 for our Y. For our text content, let's update this to be 0. All right, so one last change. Let's update our origin on this game object. So we're going to do 0.5 and 0.5. Then this way, our origin is always in the center, no matter what value we display for our score. Now that we have our basic layout in place for our game over scene, we need to add in logic to update our score value here. To do this, let's update our variable scope to be on our class, so we'll be able to access this game object from our gameover.js file. Let's jump over to our gameover.js file, and now we need to get access to our score property that was on our level scene. And so there's a few different ways we could do this. We could pass that value to our game over scene when we launch it. Another approach is we could use our global data manager, and in our level scene, we could store that value before we start our scene. And then from our game over scene, we'd be able to access that. And so that's the approach we'll be taking here. So on our phaser scenes, there's a property called registry, and this is a reference to our global data manager. And so your data manager, this is just a basic key value store. And so you provide a unique key and a value you like to store there, and then you can update it at any time, retrieve it, or delete it. And so to see an example of this, let's make a new variable, do const score. We're going to set it equal to this.registry. And now we have access to our data manager, and so we're able to use our get method, and we can provide it a key for the value we want to retrieve. So for this, we're going to do score, and as long as we store this value in our registry from our level scene, we'll now have access to that data here. So once we have our score, we can update our game object. So we can do this.score value text game object. We can call our set text method, and now we can provide it at string, and so we'll do our score. So to make this work, we need to come back to our level.js file. Down when we have our logic for where we do our game over, now we need to store our score value. So after we disable our player's body, we're just going to do this. We're going to reference that registry, and we'll do set, and now we can provide it that key. So it needs to be the same string we used before, so score. Now we can reference our current score. All right, so to test our changes, let's remove our console log here, and we'll want to start our game over scene. So if we do this, we'll do scene to reference our scene manager. Let's do start, and now we provided the scene key we want to start, and so this will be game over. And so before we test, we just need to update our game configuration to have our scene. So let's open up our main.js file. Let's copy our logic here from our UI. We'll paste it. For our scene, let's do game over. We'll update our key. We'll update our class. Then I'll come down to configuration. Let's copy this. We'll paste it. Let's do game over. And let's update our key. Be game over. Now if we come back to our browser, let's refresh. So now if we have our score, let's have our player die. So now we should store our reference to our value of 20. We'll come into our game over scene and we see our values displayed here. However, we see that our UI is still being displayed here, so we'll actually want to stop that scene. So if we come back to our code, let's go into our level.js file. Before we call scene.start, we're going to do this.scene.stop, and let's do our UI scene. So now this should stop our UI scene from running, and we should not see it in our game over scene. So now if we update our score, we'll have 35, we'll have our player die, and now we'll transition to our game over scene, and now we have our score updated here. Next for our game over scene, we're going to want to add in a nice transition for when the scene starts, and so we'll be using our camera fade in effect. To do this, we need to add in our script node for listening for when our scene first starts. So if we come over to our outline, let's do our shortcut, let's go into our utils, let's do our onAwake action script. So now once our scene starts, this will invoke this script here, and now we need to do our camera fade effect. So for this, under our script notes folder, under camera, we have this fade effect camera action script. All this script does is it references the main camera in our scene, and depending on the properties that are chosen, we'll either call our fade in or fade out effect on our camera. We then listen for the event for once that's completed, so then that way we can call the next child in our script node chain. So if we come back to our game over scene, let's choose our onAwake action script here. We'll press our shortcut for adding in our script. Let's go to our camera. We'll do our fade effect camera action script. And now for this, for our duration, let's update this to be 500 milliseconds. And we want to do our fade in complete for our event. So if we want to test our changes, let's come back over to our scene. If we refresh, if we have our player die, we should go to our game over scene. And so now instead of our scene just starting, we have that nice fade in effect. All right, so then next, now we need a way for our player to restart our game. For this, we're going to use a time event where we'll show our screen for so many seconds, and then it'll automatically start our next phaser scene. To do this, we'll also use a script node. And so under our script nodes, under our timer folder, we have this timer event action script. What the script does is it uses our built-in phaser scene timer, and we can call add event. And so what add event does, this is a mechanism for us to schedule an event that we like to happen. This event could be on a loop, it could repeat a number of times, or it could be a one-time event, and we can specify when we want this event to fire, and then we can provide a callback that we want to trigger. And so with the script here, what we'll do is we want to wait a couple of seconds, and then we want to go ahead and start our next phaser scene. To see an example of this, let's come over to our game over scene. Let's choose our on awake action script. We'll add in our script node. Let's go down to our timer. We'll do our time event action script. So on this script, we want to set our arguments for our delay. Let's do 3 seconds or 3000 milliseconds. We don't want to repeat and we don't want to loop. We just want this to fire one time. And now if we add a child script, this will be executed after that delay. So if we use our shortcut key, let's go into our scene and let's do our start scene action script. And now let's target our level scene. And that should allow us to replay our game. So now if we come back over to our browser, let's refresh. So now if our player dies, we should now fade to our next scene. And now we wait a couple of seconds, and now we should start our next scene. And so just to round out our animation, instead of going right to our next scene, we're going to add in a camera fade out effect, so then it's a nice transition. So on our time event action script here, let's use our shortcut, let's do our camera, let's do our fade effect again. And so we'll update our duration to be 500 milliseconds, but then this time we want to do our fade out complete. And so we'll want to move our start scene to happen after that fade effect. So let's do right click, we're going to do parent, and let's do move to parent. And now we want to choose our fade effect. If we save, let's come back to our level, let's refresh. If we have our player die, we should now have our fade in our game over scene. We should fade out, and now we're back to our level. All right, so to round out our scene transition, we need to add in a fade out effect on our level scene before we go into our game over scene. So for this, once our player dies, we're going to pause for a second, and then we'll start our camera transition. To do this with our node scripts, let's come into our level scene file. On the root of our project, let's add a new script node. For this, let's go into our timer, and we'll do our time event action script. Let's update our variable name, and we'll say time event action script for scene transition. For our display name, we'll say start next scene script. So now for our delay, we'll wait 1 second. We don't want to repeat and we don't want to loop. For this script, now we need to do in our camera fade effect. So let's add in our child script node. Let's go into our camera. For our duration, let's do 500 milliseconds. And we want to do our fade out event. So once our fade out is finished, now we actually want to start our scene and stop our UI scene. So let's add in 2 child scripts. For the first one, let's do our scene. We're going to do stop scene action script. For our scene, let's stop our UI scene. Now for our second script, we want to start our game over scene. So if we go into our scene, let's do our start scene action script. For our scene key, let's choose our game over. And so one thing to note, we added this script directly to our scene outline instead of under our on awake action script here. The reason for that is we don't want to trigger this script automatically when our scene starts. Instead, we want to trigger this once our game is actually over. To do that, we'll need to store our reference to the script inside our class so we'll be able to access it. So let's update our scope, and we're going to put that on our class. Now if we come back to our level.js file, let's go to our game over code. And so after we update our score here, we no longer need to start and stop our scenes. Let's remove that. So now we'll need to reference our scripts. We're going to do this. We'll do our time event action script for scene transition. And now we want to call the execute method. So now this will trigger our script. So if we want to test our changes, let's come back to our game. Let's refresh. If we have our player die, our player should now fade away. We should wait a second. And now we stop our scene. We start our next scene and we have that nice fade out effect. And so one change we'll make is we're going to hide our UI scene as soon as we start a camera transition. To do that, let's come back to our level scene. And so to do that, we just need to move our stop scene action script. So if we do right click, let's do parent, let's do move to parent. And now we just want to have it be triggered from our start next scene script here. So now if we save, let's refresh. Now if we have our player die, once our player fades away, we should wait a second. We should now hide our UI and start our fade out effect. Very nice. So next, we're going to work on creating a title screen for our game. So instead of starting our level scene automatically when our game starts, we'll now launch our title screen and our player will have to click to actually start our game. To do this, let's come back to our editor and let's make a new phaser scene. Under our scenes folder, we'll right click, we'll do new, let's do a new scene file, and we'll call this title. So now for our title screen, we're going to set up a similar background that we did for our level scene. So if we come over to our level scene, I'm going to copy our level layer and our player layer. So let's just copy both of these. So we come down to edit, let's do copy. We'll come over to our title scene. Let's paste those in. So now for our player, let's update our player's position. So for our player's position, we'll keep the same X value, but then for our Y value, let's do 136. Next for our title screen, let's add in our ground image. So our player will be standing on that instead of floating in the air. Let's choose our level layer. Let's drag in an instance of our image block. For our positioning, let's update our X value to be 0. For our Y position, let's do 144. And now let's update our origin and we'll do 0, 0. Next, let's update our offset for our tile for our right wall. So then that way it's not mirroring what's happening on our left wall. To do this, if we come over to our inspector, let's go to our TileSprite. Let's override our default value for our Y position on our tile position here. And let's go ahead and do negative 120 so it lines up with what we do in our level. Next, for our title screen, let's add in our title text for our scene. Let's go to our built-in blocks. We'll go to string. We'll drag in our text game object. So now for our text game object, let's update our variable name. We'll do our title text game object. We'll do title text for our display name. For our position, let's do 32 for our X. We'll do 15 for our Y. Now for our text content, let's do warped, cave. We'll do a new line and we'll do escape. Let's use our press start 2P font family. We'll stay with 16 pixels. Let's update our text alignment to be centered. And now we're going to update the color on our text. So for our color, we'll do 00 ACE 1FF. Now for our stroke, let's do 00 FF. Next for our text, we're going to have it stand out a little bit more by adding a shadow to it. So for our shadow, let's do a stroke and we'll do a fill. For our offset, let's do 3 for our X, we'll do 1 for our Y, and then let's update our line spacing and we'll do 3. Now that we have our title text, let's do one more text game object. For this text game object, we're just going to have the text say click to play, and we'll have this text flash, so then that way it indicates the player needs to interact to begin the game. Let's update our variable name, so we'll do our click to play text game object. For our display name, let's do click to play. For our position, let's do 68 for our X, 81 for our Y. So now for our text content, let's do click to play. We'll use our custom font. For our font size, let's do 8 pixels. So now for our color, let's do 59006 EFF. For our stroke, we'll do 000, and let's go ahead and save. So now if we want to test our changes with our title screen, we'll need to add this to our game configuration. So let's open up our main.js file. Let's import our new class. So we'll copy our import statement here. We'll update this to say title, update our class name. Now down here, let's add in our class. So we'll do title, and we'll do title. Now we'll need to update our preload scene to go to our title screen instead of our level scene. So if we open up our preload.js file, down at the bottom in our create method, let's change level to title. Now if we save, we should be able to come back to our browser. If we refresh, we should see our new title screen. So one thing we'll need to fix right away is we need to disable our player's body. So if we come back to our code, let's open up our title.js file. Let's come down to our create method. In our create method, after we call editor create, let's disable our player body. And so we'll do this, we'll do our player, let's do our body, we'll do enable, we'll set it equal to false. Now if we come back to our browser, let's refresh. Now we'll have our player on our screen and we're doing our idle animation. All right, so now for our title screen, let's add in our camera fade in effect so we have that nice transition. For this, let's open up our game over scene. From our game over scene, let's go into our outline. Let's copy our on-awake action script here. We'll come back to our title screen. Let's paste that in. So now when our scene awakes, we'll want to do our camera fade in effect, but we don't need to do this time event action script, so let's remove that. So now if we save, let's come back to our browser. Now we have that nice fade in effect when our game starts. All right, so right now our scene's a little bit static, and so we're going to update our click to play text to be animated, and so we're going to have it flash, and so we're going to update its alpha between 0 and 1. So that way it indicates the player needs to click to start our game. And so to do this, we'll use a new script node. Under our script nodes folder, under animation, we have this tween action script here. What the script does is it creates a phaser tween, and we can provide which property we want to modify on our target game object. So back in our title screen, let's click on our onAwake action script. We'll add in a new script. Let's go to animation, let's do tween. For this, in our inspector, we need to choose our target game object. Let's choose our click to play text. So now for our properties, for the duration of our tween, let's do 1200 milliseconds. For yo-yo, we want this to be true. We're going to want this to repeat, so let's do -1. Let's add in a slight delay, so it doesn't start right away. So we'll do 500 milliseconds, and we'll add in a delay between each loop, so we'll do 500. Now we need to provide the property we want to modify. We want to modify our alpha property, and now we can choose which value we want to tween it to. So currently our alpha is at 1. Instead of going straight to 0, let's do 0.2, so then that way it'll be pretty transparent. Alright, so if we save our scene, let's come back to our browser. If we refresh, we'll see now our text is now animated, and now it'll flash to the player. Next up, now we need to add in our input handling, so when we click on our screen, we actually start our game. So for this, we'll be using another script node. Under our script nodes, under our scene folder, we have the scene on pointer down action script. So in this script, we just listen for our pointer down event, and then once the player clicks, we execute the next node script in our chain. So if we click on our onAwake action script, let's add in a new child script node. Let's do our scene. We'll do our scene on pointer down. And let's toggle once because we only want to trigger this callback one time. So now when the player clicks on our screen, now we want to launch our level scene. So let's add another child script node. We'll do our scene. Let's do our start scene action script. So now for our scene key, we'll want to choose our level scene. So now if we save, let's come back to our browser. All right, so we refresh our browser. If we click on our screen, we'll see now we jump right into our level scene. So we're going to want to add in our camera fade out effect before we transition to our next scene, and we'll want our camera fade in effect on our level scene. But before we do that, we're going to spruce up our title screen a little bit more. We're going to have our player do a little bit of an animation, and we're going to add a glowing effect to make it look like our player launches into the air. And once that animation is done, we'll use that to actually trigger our fade out effect for our current scene. So to add in this logic, we're going to want to listen for after our player clicks on our screen, and once that happens, we'll want to call a new method on our title scene class instead of directly starting our level scene. So for this, let's remove our start scene action script from our scene on pointer down action script. Instead, let's add in a script. We'll go into utils and let's add in this callback action script. And so what this script does is we can provide a callback function that we like to invoke when this script node is executed. So for our callback, let's just add in our arrow function. And for this, we'll want to call a new method on our scene class. So for this, let's do this. We're going to do start game. Now if we save, let's come into our title.js file. We need to add that method to our class. So let's do start game. Let's do console.log test. Come over to our browser. Let's open up our inspector. If we refresh, now when we click on our scene, we'll see we no longer launch our level scene, but we can see that our click event is calling our method. So now in our start game method, this is where we'll do our logic for having our player launch into the air. And to create this animation, we're going to stop playing our idle animation. We're going to have a player crouch down, and then they're going to fly up into the air. And so to create this effect, let's come back to our code. In our start game method, let's get rid of our console log. First, let's stop our animations. We'll do this stop player.stop. Now we'll want to update our player's frames. We'll do this. We'll do our player. Let's do set frame. Let's do player. We'll do duck.png. Come back to our title screen. Now when we click, we'll see our player ducks down. And now we want to wait a second, and then we'll have our player launch into the air. To do that, we're going to do this.time. We'll do delayed call. Now we can provide how long we want to wait. Let's do 1 second. So we'll do 1000 milliseconds. And now we can provide the callback we want to be invoked. And so in our callback, we're going to play our player's idle animation. So we'll do this.player. Let's do play. And we'll do our player idle for our animation. Next, we'll want to re-enable our player's body, and then we'll update our velocity. So I'm going to copy this line of code here. Let's paste it. We'll update this to be true. And now we want to do this.player, our body. Let's do our velocity. And for our Y value, let's set that equal to -1000. So that way it'll launch our player really fast. So now if we come back into our browser, let's refresh. Now when we click, we'll see our player crouches down, and now it looks like they jump way up into the air. So once that's done, now we need to do our camera fade out effect and transition to our next scene. So for this, we'll want to copy the logic like we did in our level scene, where we have a script node that's not invoked at the start, but we'll execute it from our code. So let's copy our script node here for starting our next scene. Let's come into our title scene. Let's paste that in. So now for the script node, we don't need to do stop scene since we don't have our UI scene. We'll want to do our camera fade out effect, and then for starting our scene, we don't want to go to game over, we want to go to our level. So now back in our title.js file, in our callback here, now we want to trigger that script. So let's do this.time, event action script for scene transition, and we'll call execute on that script node. So now let's refresh. We click on our scene, our player should launch in the air, we should fade out, and now we're taken to our level scene. So the last thing we need to do for our scene transition is now we just need to add in our fade in effect to our level scene. So we come back to our level scene. Let's go into our onAwake action script. Let's add in our child script node. Let's do our camera. Let's do our fade effect. Let's do 500 for our milliseconds. And for our fade event, let's do our fade in complete. And now we want to launch our UI only after our fade in effect has completed. So let's do parent. We'll do our onAwake action script, and now let's choose our fade effect on our camera. Now if we save, let's come back to our title screen, let's click, we should fade out, we should fade in, and now we have a nice transition. So for our title screen, the last thing we're going to do is we're going to add a glow effect to our player. We're going to make it look like that our player is storing up energy and getting ready to do that super jump into the air. To do this, let's come back to our code, let's go into our title.js file. So now to create that glow effect, we're going to want to use our postfx on our game object. So let's make a new variable, do const, let's do glowFX. We'll set equal to this.player. Let's reference our postfx pipeline. We'll do add glow. Now for our glow, for our color, let's do 0x00ff. Now for our strength, let's do 1. Our inner strength, let's do 0. Let's do false for knockout. And then for our quality, let's do 0.1. And we'll do 5 for our distance. So what this method does is this creates a nice glowing effect around our game object. The color is going to be the color of that glow, and then our strength is going to control how bright or how far out that glow actually goes. If we save our code and come back to our browser, if we refresh, we'll see now we have this nice blue glowing effect around our player. We come back to our code, if we update our outer strength to be like 4, and now we come back to our scene, we'll see our glow effect is much stronger and it really stands out. So then by modifying these arguments here, we can control what that glow looks like. All right, so now to make it really stand out, we're going to add a tween to modify the strength of our glow effect. So let's come back to our code. Let's add in our tween. So we'll do this.tweens. Let's do add. And for our configuration, for our target, we want to target our glow FX. Now for our outer strength, let's set that to 4. For our duration, let's do 800. Let's add in our yo-yo property. We'll set that to be true. And finally, we want this to repeat. So let's set this to -1. Come back to our browser and refresh. Now we'll see this nice glow effect on our player. All right, so the last thing we want to do for our glow effect is after our player launches into the air, we want to make it look like that they've expended all that energy. And so we're going to clean up our glow effect. So now to clean up our tween and our glow effect, we just need to store our reference to that on our class. So outside our create method, let's do glow tween for our property. Now where we create our tween, let's store that on our property. So we'll do this.glow tween will be equal to this tweens.add. So now in our callback, before we start our next scene, let's clean up our tween. So we'll do this.glow tween. We'll call destroy to clean up our game object. And now to get rid of our postfx, we'll do this.player. We'll reference our postfx pipeline. And now we call clear to remove our special effects. So now if we come back to our browser, let's click, we'll see our player crouches down, our glow effect goes away, and now we launch into our level scene. So with those last changes, that actually wraps up our title scene, and now we just need to make a few more changes to finalize our game. First, let's go into our gameover.scene file. When our scene's over, we're currently going back to our level scene, and we want to drop our player back onto our title screen. To make that change, let's go into our start scene action script here. Let's update our scene key, and we want to transition to our title scene. Next, in our main.js file, let's disable our debug for our arcade physics. And finally, we're going to update our default background color, and so we're just going to make this black. So we'll change this to 000, 000. Now if we come back to our game, we should be able to test our full game end to end. So if we click, we should jump into our level scene. So now we'll have our game and we can play it. So if we go ahead and try to get to 200 for our score, we should see our moving platforms. And so once we reach past 200, our platforms should start appearing, and some of them should be moving and some of them should be stationary. So now if we have our player die, we should have our die animation. Now we should transition to our game over scene, and now we can see our score that our player received for that round. And that's it. Congratulations, you've just built your own infinite jumper game with phasereditor v4. From creating reusable prefabs to crafting a stunning parallax background and connecting scenes, you've taken some powerful steps toward mastering game development with Phaser. Now that your game is up and running, here are a few ideas to take it to the next level. A dynamic difficulty, you can make the game more challenging over time by increasing the player's speed, introducing new obstacles, and new platform types. You could customize the theme, you could experiment with new tile maps, sprite designs, and music to give your game a completely different vibe, maybe a sci-fi setting, jungle theme, or even a snowy landscape. You could add in online leaderboards, you could integrate a simple backend to allow players to submit high scores and compete with friends, achievements, you can create milestones for players to reach like jump 100 times or survive for 2 minutes. These enhancements not only make your game more engaging, but also give you the chance to explore even more features in phasereditor and Phaser 3. If you enjoyed this tutorial, please give the video a like and subscribe for more game development content. I'd also love to see what you create. Share your games in the comments down below. Thanks for watching, and I'll see you in the next video. Happy coding and keep creating.